Frank, Mary and Seth shared some sweets in the ratio 4, 5, 7. Seth got 18 more sweets than Frank, and we need to work out the total number of sweets they shared. Okay, so I'm going to write this out here so it's a bit clearer. So we got Frank, what I'm going to say is F, Mary M, and Seth S, and they shared the sweets in the ratio 4, 5, 7. Now this is the key part. Seth got 18 more sweets than Frank. And if we just decode the wording in the question, we're saying Seth got 18 more sweets than Frank. So what we're referring to, the difference between Seth and Frank. Because we know that Seth got 18 more sweets than Frank. And when we mention difference, we'll talk about subtraction. So we know we're going to have to use subtraction. I'm going to go back over to the ratio here. So we're talking about Seth and Frank specifically. So these two here. And we know we're talking about the difference. So I'm going to work out the difference. And because Seth got more sweets than Frank, I'm going to do Seth minus Frank. So we've got 7 minus 4. So the difference between them. And that equals 3. I'm going to label this here. And hopefully it will make sense in a minute. I'm going to label it as the ratio difference. So this isn't the actual amount of sweets they've got. This is just the ratio between the different people. However, we know in real life the actual difference is 18. Because Seth has got physically in real life 18 more sweets than Frank. So labelling this, I'm just going to call it the real life difference. So now what we need to work out, our job is to see how we can get from this, the ratio difference, up to the real life difference. So what the link is between these two. Now, because we can see that the number's getting bigger, we know, okay, so it's not subtraction or division, so it must be additional multiplication. However, in this case, when we're working with ratios and things like that, we're going to be using multiplication. So we need to work out what 3 multiplies by to get 18. We're going to think of that by thinking of an equation. If we've got 3 multiplied by something, so I'm going to call it x equals 18. And we're going to try and work out what this x is. So we're going to divide both sides by 3. So we divide the left by 3 and the right by 3. These 3's will cancel. We'll be left with x. And 18 divided by 3 is 6. So here's our key number here. Here's our link between the ratio difference and the real life difference. So I'm going to put that up here. We're going to multiply by 6. Fantastic. So now using this, I'm going to start working over here. I'm going to look back to the question. We need to work out the total number of sweets they shared. So I'm going to use the same thing because we know now there's a link we've got between the ratio and real life. So I can use that in the next part. So in the ratio, Frank's got 4, Mary's got 5, and Seth has 7. So in total, we're going to have 4 plus 5 plus 7, which is going to equal 16. So this, I'm going to call it again, as similar to last time, the ratio total. However, what the question is we're going to ask to work out what the total number of sweets they shared are. So in real life, what's the actual amount of sweets that they had and they shared all together? So you want to work out the real life total. So we're going to use our key bit of information we worked out here. We worked out the number that's linking the ratio to real life is 6. So again, we're going to do the same thing here. Here we multiply by 6. Here we're going to multiply by 6. So we've got 16, which is our ratio total. We're going to multiply that by 6. And that gives us 96. And because this is a calculator paper, we can just put that into our calculator and speed up our working. And this is the answer here. 96 is our real life total, so the amount of sweets that they had. So we're going to write that down here in the answer box. And this question right here is a 3-mark question. So we're going to work out where we got the marks. So the first mark is over here, working out this 6. We've got to employ some sort of strategy to work out this 6. So if you get down to this answer of 6, you get a mark. Next mark for this part here. So work out, we need to add them all up to get 16 and multiply that by 6 to get the total. So you get a mark here for this sort of section working over here. And then for getting the correct answer of 96, we get our third and final mark. So PQR is a right angled triangle, and we can see a little diagram of that triangle here. We need to work out the size of the angle marked X and give our answer to 1 decimal place. And this is for 2 marks. Okay, so the first thing that we can see is that PQR is a right angled triangle. It says that in the question. We can also see that from the diagram here with this little square, meaning it's a right angle. It's quite often when we see a right angle triangle in the question, our first thought should be trigonometry. And when we think of trigonometry, we quite often think of SOHCAHTOA. So this is a nice way of remembering our trigonometric ratios. I'm going to use this here to help us a little bit later. First of all, we're going to look at the triangle here. And we need to label our sides. So we've got 3 sides to label. We've got the opposite, adjacent, and hypotenuse. So the first one is the opposite. And the way we find out which side that is we go to the angle we want to find out. So in this case, this one here. And then we draw a line coming directly out of it and see which side it hits. So this one. So it's the opposite because it's the side that's opposite to the angle that we want to find out. Equally, you can also think of it as the side of the triangle that doesn't touch the angle we want to work out at all. So I'm going to label that side O for opposite. The next one to find out is the adjacent. Now the adjacent is the side that touches both the angle we want to find out and the right angle. So it's this side here, that side that touches both of them. So that is the adjacent side. Then the final side here, so the sort of sloped side coming down here, is the hypotenuse. So I label that H. Now when you think about which sides are going to be useful, so which sides do we have information for? Well, we haven't got any information for A, the adjacent side, because it doesn't tell us what length it is. However, for the hypotenuse and the opposite, we know, okay, so this is 5 centimetres and this is 14. These are the ones we're going to use because they're helpful. We've got information about them. So we go back over to the little helpful SOHCAHTOA I wrote out here. We're going to see which one involves O and H. So if we look at these parts of the word here, we've got this one is A and H, this is O and A, this is O and H, and we want to use this one because that's what we've got. We've got some information for O and H. So we're going to use this one, and then we look at the letter here. See, that's an S, so that means sine. We're going to have sine of an angle, so I'm going to represent that with a theta here. So sine of theta equals opposite over hypotenuse. So essentially this right here is a way of remembering it. And this represents this. So this is what we're going to use. This is our trigonometric ratio. So using this, we've got sine. And we're going to replace theta with the angle we're working out. Well, the angle we're working out here is x. So we're going to have sine x. And that's opposite over hypotenuse. So opposite is 5 centimetres and hypotenuse is 14. We're going to do that. So our next step is to work out what x is. And the way we do this is by using inverse sine. So we can say x equals the inverse sine. So we write that as sine to the minus 1 of 5 over 14. And what you can do, you can put this straight into the calculator. And doing that, we get that x equals 20 point. And then we've got lots of decimal places. So I'm going to write down a few of them. We've got 9, 2, 4, 8, 3, ... So it keeps on going. But if we refer back up to the question, it says we need to give our answer to 1 decimal place. So we need to round this to 1 decimal place. So we're going to say x equals 20 point. And then to round to 1 decimal place, we look at the one after the point. So we've got 9. Then we look at the number after that. And we think, is that 5 or above or lower than 5? If it's 5 and above, we would take this number and raise it up 1. If it's less than 5, we would keep it the same. So 2 is less than 5. So we're going to keep the 9 the same. And we've got 20.9. And that's the answer to 1 decimal place. And handily, they've already included our little degree sign here, so we don't need to worry about that. And for this question, we get 1 mark up here. So for working out that sine x equals 5 over 14, we get the second mark for getting the correct answer of 20.9 degrees. Here are the first 4 terms of an arithmetic sequence. We've got 6, 10, 14, and 18. And part A says we need to write an expression in terms of n for the nth term of this sequence. And this is for 2 marks. Now the first step we've got to do is work out the difference between these terms. So between these 2 terms, the difference between 6 and 10, so that's 10 minus 6. So we've got 4. Now I'm going to look between these 2 terms. Well, the difference again is 4. We're now going to look between these 2 terms, and the difference again is 4. So that's great. Now we've identified this number here. So this is our key number we're going to be using in the next step. So now below it, what we're going to do is write out a 4 times table. So we're going to write out the times table of the difference here. So I'm going to write out here, we're writing out for n basically, where we're going to sub into n different numbers. So for example, for the first term, we're going to sub n equals 1, second term n equals 2, and so on. And this is the first term, so we're going to sub n is 1, so that's 4 times 1, so that's just 4. Then so on, so the second term, we're subbing n equals 2, so that's 4 times 2, so 8. Then 4 times 3 for the third term, which is 12. And then 4 times 4 for the fourth term, which is 16. So essentially, all we're writing out down here is the 4 times table. Now the next step is we need to work out how we can get from this line to this line. So essentially work out the difference between the terms here. We can pick any of them to look at, but I'm going to look at this one first. So we're going to pick 6 and 4. We're going to work out the difference between 6 and 4. So we've got 6 minus 4 equals 2. So to get from this line to this line, we add 2. So as you can see here, the difference every time is 2. So 2 is our new key number that we're going to be using. And hopefully it's a bit clearer now. So along here we worked out the difference between the terms. And here we did the times tables of the differences. And then we worked out the difference between the original term here and the times tables term. And we can see that's consistent through all of them. And that's 2. So our final step is we're going to bring it all together. We're going to bring in this part and this part to get our nth term. So therefore, our nth term is 4n plus 2. So it's whatever our times table part was over here, adding on to it the difference here. So you get 4n plus 2. I'm going to write that in the answer box here. And if you see where we get the marks, we get 1 mark for sort of starting to go through the process and realise, okay, so we've got this 4n part here. And then our second mark for getting down to the correct answer of 4n plus 2. So now look at the next part here, we see that the nth term of a different arithmetic sequence is 3n plus 5. In part B it says, is 108 a term of the sequence? And we need to show how we get this answer. So essentially we need to answer this question, is 108 a term or not? So what I'm going to do is start off by assuming that 108 is a term. So 3n plus 5, if 108 is a term, from that we'll be able to get 108. So there'll be some value of n that we're subbing here, which will get us to 108. So I'm going to try and work out what that value is. So I'm going to sort of solve this equation. So 3n equals 108 minus 5. So 3n is 103. And if I divide both sides by 3, we'll have n equals 103 divided by 3. And because this is a calculator paper, we can do that. If you just put it into the calculator, we find out that that is 34.3 reoccurring. Okay, so if we just have a think for a second, the way we get 108 as a term is if we sub n to be 34.3 reoccurring. So this shows that 108 isn't a term in the sequence. This is because we know n could only be 1, 2, 3, 4, 5, so on and so on. We can't have any decimal numbers like this, for example, because you can't be in between two terms. They're discrete values. So we've got a term at n equals 1, a term at n equals 2, a term at n equals 3, and so on. But we don't have a term here. So no. It's important to put this bit in, so no, because we're answering the question. It's saying, is it a term? We're saying no, because 34.3 recurring isn't an integer. So it's not possible, because we know n can only be values. So for example, 1, 2, 3, 4, it can only be integers. So seeing where we get the 2 marks from, we get 1 up here. So for starting a method like this, then we get a second mark for realizing, okay, so n isn't an integer, so it's impossible, so the answer is no. And then saying no and writing a convincing argument here. So like this, just saying that it's not an integer. I also want to point out here an alternative method you could have used. This one involves a bit more of sort of trying numbers, but for example, we know our sequence is 3n plus 5. And we need to think what sort of numbers would get us around 108. So if I try 30, we could try n is 30. We get 3 multiplied by 30 plus 5. Okay, so that gets us 95. So it's not quite to 108. So I might try something else. So I'm going to try n equals 34. To get 3 multiplied by 34 plus 5 equals 107. Okay, so we've got 107 as our 34th term. So it's going to be impossible to get 108. But just to show that definitely, we're going to try the next term. So if the 34th term is 107, we're going to do the 35th term. It's going to do 3 multiplied by 35 plus 5, and that gives us 110. So as our 34th term is 107, and our 35th term is 110, we know that 108 isn't a term because there's nothing in between the 34th term and the 35th term. So as our conclusion, we could say, since the 34th term is 107 and the 35th is 110, no, 108 isn't a term in the sequence. So in this working of it, you get 1 mark for doing some of this work here, and get another mark for saying no, and sort of giving a little bit of an explanation for it.
Axel and Lethner are driving along a motorway. They see a road sign. The road sign shows the distance to junction 8. It also shows the average time drivers take to get to junction 8. So here's the information here. So we see to get to junction 8, it's 30 miles, and that on average takes a driver 26 minutes. The speed limit on the motorway is 70 miles an hour. And Lethner says, we will have to drive faster than the speed limit to drive 30 miles in 26 minutes. Is Lethner right? And we need to show how we get to our answer. So firstly, we're going to have a look at what 70 miles an hour means. So 70 miles per hour means you can travel 70 miles in 60 minutes. So it's miles per hour, and an hour is 60 minutes. So you can travel 70 miles in 1 hour, so 70 miles in 60 minutes. So now using this, we can work out what speed 30 miles in 26 minutes represents. So to work out what this is in miles an hour, we need to change this to say in 60 minutes, because it's in miles per hour. So we need to work out what you multiply 26 by to get to 60. And we can do that divided by 60 by 26. So if we do 60 divided by 26, and because it's a calculator paper, we can just put that into the calculator. And because it's a long decimal number, I'm just going to write it as a fraction. So we've got 30 over 13. So this means if we times 26 by 30 over 13, we get 60. So now what we can do is sort of treat this a bit like a ratio. So you've got a ratio of 30 miles to 26 minutes. But what we're going to do, we're going to get the ratio to be in 60 minutes. And we're going to use our multiplier we just worked out here. So just to check that we got it right, we're going to start with our minutes first. We're going to have 26 times by our multiplier here, 30 over 13. And that gets 60 as we would expect. So we know we've worked that out right. And now we can also now multiply our miles part by our multiplier we worked out. It's going to have 30 multiplied by our multiplier, which is 30 over 13. And that gives us 900 over 13. And we're going to write that as a decimal. So that's going to give us 69.23, rounding that to 2 decimal places. Okay, cool. So if we think about this, this is our minutes. So it's in 60 minutes. And these are our miles. So writing this sort of out here in a sentence, you can go 69.23 miles in 60 minutes, which is 69.23 miles per hour. So now finally we need to make a conclusion related to the statement, we will have to drive faster than the speed limit to drive 30 miles in 26 minutes. Well, the answer is no, you won't have to drive faster than the speed limit because the speed limit is 70 miles an hour. And we've just worked out it's possible to do that distance in that many minutes going 69.23 miles an hour, which is less than the speed limit of 70 miles an hour. So to get the mark, we need to write that in some sort of conclusion. So I've written it as my conclusion here. 69.23 miles an hour is less than 70 miles an hour. So no, Lethner is wrong. And it's important here to say the word no, because we need to look back at the question. We always need to remember to answer the question when we have to do a statement like this. We're answering the question, is Lethner right? And the answer is no, and this is why. So if we look to see where we get the marks, we get 1 mark here for working out this multiplier. We get another mark here for using that to work out this number here, so 69.23. So we know it's going to be 69.23 miles an hour. Then we get our final mark here for a conclusion, something along these lines. The table shows some information about the foot lengths of 40 adults. So part A says we need to write down the modal class interval. So we look at the word modal. In this context, we're referring to the highest frequency. So we need to look for the highest frequency class interval. So here are all our class intervals, and here are our frequencies along here. So our modal class interval is going to be this one here. So the foot length being greater than or equal to 22 and less than 24. And that's because it's got the highest frequency, so we've got 12 here. which we can see is the highest out of all of these. So we need to write down the correct class interval here in order to get the 1 mark. So next part B says we need to calculate an estimate for the mean foot length. So I'm going to go straight back up and we're going to do some work with the table up here. I'm actually going to add in a couple of extra columns. Okay, so the way we work out the mean from a frequency table when we've got grouped data like this is we use the midpoint. So we're going to work out the midpoint of all of these groups. And I've created a column here where we're going to write them down. So to work out the midpoint, I'm going to use this group for an example. We do this number plus this number and divide by 2. So in this case, we've got 16 plus 18 divided by 2, which is 34 divided by 2, which equals 17. So that's the midpoint for this group here. Then we do the same thing for all the other groups. So now I've got another column here, which is f multiplied by x. So I'm using f here to represent the frequency. And this here is our column that is our frequency, so number of adults. So in this column, what we're going to write down is our midpoint, so we worked out here, multiplied by our frequency, so the number of adults in this column. So in this row, we're going to do 3 multiplied by 17. And the next one, we're going to do 6 multiplied by 19 and so on. So great, now we've done that, the final thing we need to fill in is our totals. So we need to write down here the total number of adults. And we could do that by adding these numbers up individually. But actually, helpfully in the question, it tells us there are 40 adults. So we add up the number of adults, we get 40. And then what we're going to do here, we're going to add up all of these numbers. And when we do that, we get 876, which I'm going to write in there. Okay, great. So now we've got all the information we need to estimate the mean foot length. So when you usually think about a mean, you think about everything added up, divided by how many things there are. That's the sort of phrase you can use to think about it. And it's the same thing here. So we've got the total frequency multiplied by midpoint, so f multiplied by x, divided by the total frequency. So the number of adults in this case. So we get 876 divided by 40. And popping that into the calculator, we get 21.9, which is our final answer. So writing that in the answer box here, we have 21.9 centimeters is our estimate for the mean foot length. So in this case, we get 1 mark for working out all the numbers in this column over here. So you get 1 mark for our midpoint multiplied by frequency column. We then get another mark for realizing we need to add all those numbers up and divide it by 40, so the number of adults. And then we get our third and final mark for the correct answer of 21.9. Now, one thing I just quickly want to point out is that we're working out the estimate for the mean. And that's because we've got grouped data up here. For example, these 3 adults could be anywhere within this range. So all 3 of them could have a foot length of 16. All 3 of them could have a foot length of 17. Or they could be a mix between 16 and 17. But we just don't know. So we've taken the midpoint and used that to work out the mean. So it's a good guess, it's a good estimate, but we don't know it's the exact mean because these adults could be anywhere within these ranges. So that's why what we've worked out is the estimate. Triangles ABD and BCD are right angle triangles. And the question says we need to work out the value of x, giving our answer correct to 2 decimal places. So essentially the question is asking us to work out the length of this side here. Now, the first thing that jumps out to me, because we're working with the right angle triangles, is Pythagoras' theorem. Now, a quick reminder of what that is. So this works with right angle triangles. So if we got this side here to be A, this side here to be B, and this side here to be C, it states that A squared plus B squared equals C squared. So if we know these 2 lengths here, we can work out this length. So we can implement that and use that to work out what x is here. The issue we currently have is we don't quite have enough information to work out this x, because we only know one side from this triangle, BCD. We only know 4 centimeters. However, to use Pythagoras' theorem, we need 2 bits of information. So we're going to use this triangle, which does have 2 bits of information, to work out this side, which then gives us 2 bits of information to be able to work out x. So hopefully it will make sense as I go along. So I'm going to label this side y centimeters. And if we refer over to Pythagoras' theorem over here, for this triangle, so for triangle ABD, we're going to say y squared plus 5 squared equals 10 squared. So now we can rearrange this. We're going to make y squared the subject. So we're going to subtract 5 squared from both sides. So we're going to have y squared equals 10 squared minus 5 squared. And we're going to say y squared equals. I'm going to put this into the calculator to find out what it gives us. And we get 75. So we know that y squared equals 75. And I could go further and try and get y by itself and square root both sides. However, I'm not going to do that. And you're going to see why later. That's an irrelevant step and there's no point doing it. So we're now going to work with this triangle here. So for triangle BCD, and what we're going to have there, we're going to have y squared plus 4 squared equals x squared. Now, what we can see here, we've got y squared here, but we know, because we worked out in the previous step, what y squared is. So we can sub that in, and we can see why we didn't square root this now, because if we did, we'd just have to square it again. So using y squared equals 75, we're going to have 75 plus 4 squared equals x squared. And if we work out what 4 squared is, that's 16. So we've got 75 plus 16 equals x squared. And if we add these together, so that's 91. So I'm going to write it the other way around so it makes a bit more sense. We've got x squared equals 91. And so to get x, we're going to square root both sides. So what's important to note here is because we've got an equation here, and we're going to square root, we're going to introduce a plus or minus. So we're going to have plus or minus the square root of 91. Now this goes conventionally, just the square root symbol, that will give us the positive square root of a number. But because we've got an equation here, x could either be positive or negative. So we've got to put this plus or minus outside of the square root here. So we need to think about this for a second. We've got two answers for x. So which one's it going to be? Well, in the context of the question, we're looking at a length here. So it's going to have to be positive because you can't have a negative length. So I've written that out here. So x is a length. So we're going to reject negative the square root of 91. So x is just equal to the square root of 91. But going back to the question, it said give our answer correct to 2 decimal places. I'm going to put that into the calculator, square root of 91, and to 2 decimal places, that will be 9.54. Great, and we're just going to write that into the answer box. So seeing where we get the 4 marks, we get the first mark up here for getting to the y squared being equal to 75. Second mark down here for this part, so we got the 75 plus 4 squared equals 91. We get our third mark for square rooting to make x the subject of the equation. Then we get the fourth and final mark for a correct answer of 9.54. The graph of y equals f of x is drawn on this grid here. And part A says we need to write down the coordinates of the turning point of the graph. So look at the graph here, the turning point is up here. It's a part of the graph where the gradient is 0. So we go in this direction, and then we're moving to this direction. And the point where we switch between the directions there is the turning point. To work that out, I'm just going to look along here. So on the y-axis, the turning point we can see, okay, that's at 4. And now we're going to need to look at the x-axis. So if we go down here, we can see that, okay, so that's x equals 1. So the coordinates of the turning point is 1, 4, because x equals 1 and y equals 4. So now we're going to move on to part B. So now for part B, we need to write down the roots of fx equals 2. And to do this, we're going to follow these 2 steps. So firstly, we're going to draw the line y equals 2. And that's because we need to find the roots of when fx equals 2. Secondly, we're then going to look to see where the line y equals 2 that we've just drawn intersects the curve. And the x coordinates of those points where it intersects are the roots. So hopefully it'll become clear in a minute when we do it. So I'm going to draw a line at y equals 2. Okay, now I'm going to use a blue for this so we can see it clearly. So if I draw a line along here at y equals 2. And now we need to look at the points where it intersects. Well, that's here and here. And now the roots are the x coordinates of these points. So if we look down here, that's going to be at 2.4. And now at this point, if we draw a line down here to see, that is going to be at minus 0.4. Fantastic. So now we found out both the roots they want, and we're going to write them down in the answer box here. So we've got 2.4 and minus 0.4. Last but not least, part C says we need to write down the value of f of 0.5. So here are the 2 steps we're going to use for this question. So firstly, we're going to draw the line x equals 0.5, because we write down the value of f of 0.5. And then for the second step, we're going to write down the y coordinate of the intersection, because this is going to be the value of f of 0.5. Okay, so here is x is 0.5. So I'm going to draw a nice long line at that point. So now we look for where that line intersects the curve y equals f of x. And that's up here at this point. So that's halfway between 3.7 and 3.8. So it's going to be 3.75. However, it is quite hard to tell exactly where it is, so the mark scheme would accept anywhere from 3.7 to 3.8. And fantastic, now we've worked that out, all is left to do is write 3.75 in the answer box here. And in this question, you just get 1 mark for getting the correct answer in each part. In a box of pens, there are 3 times as many red pens as green pens, and 2 times as many green pens as blue pens. For the pens in the box, we need to write down the ratio of the number of red pens to the number of green pens to the number of blue pens. And this question is for 2 marks. Okay, so we're going to go through the question really carefully and break it down. So firstly, starting with this line. So this line looks at red pens and green pens. So you've got red and green. And there are 3 times as many red pens as green pens. So writing that as a ratio, it's going to be 3 to 1. Because for every 1 green pen, there'll be 3 red ones. Because there are 3 times as many red pens as green pens. Okay, now separately, we're going to have a look at the second line. There are 2 times as many green pens as blue pens. Okay, so we're working with green and blue. And 2 times as many green pens as blue pens. So it's going to be 2 to 1. So if we've got 1 blue pen, there'll be 2 green pens. Fantastic. So now the final part is combining both of these into a single ratio. And to do this, we need to look at what's common between them both. Well, what's common is the green pens. And so to combine them, we need these 2 numbers to be the same. Now we can either divide this ratio by 2, which will make this number 1, matching this one, or we could times this ratio by 2, making this 2, matching this one. I think it'd be better to times this one by 2, because otherwise we'll get a decimal here, which isn't very nice to work with. So we're going to multiply this ratio by 2. When we're working with the ratios, we need to remember to multiply both sides, because we need to keep them equivalent. We need the new ratio that we have to be equivalent to the old ratio. So doing that, we're still going to have red and green, but the ratio now is going to be 6 to 2. And we're going to leave the other one the same. We've still got green to blue, which is a ratio of 2 to 1. And what's great now, because these numbers are the same, we can write this as the ratio of red to green to blue being 6 to 1. And that right there is the final answer. Okay, so we get the first mark for these statements here. So interpreting the question and making them into these ratios. Then we get the second mark for then combining them together to get the final correct ratio. ABCD is a rectangle and EFGH is a trapezium. All measurements are in centimetres and the perimeters of these 2 shapes are the same. And the aim of the question is that we need to work out the area of the rectangle. And this is for 5 marks, so it's quite a big question, so we need to work through this logically, step by step. So first I'm going to take a look at both these shapes. Now a key bit of information that we get given first in the question is that the perimeters of the 2 shapes are the same. You get the perimeter by adding up the lengths of all the sides of the shape. And that works the same for the rectangle here, and also for the trapezium here. You add up all these lengths to get the perimeter. And the fact that this has x's in it doesn't matter for the minute. We can still add them up. So that's what we're going to do. So firstly, the perimeter of the trapezium. So we're just going to add up all the lengths of the sides. So we've got x minus 3 plus 5x plus 7x minus 3 plus 5x. And we can do what's called collecting like terms. So anywhere where we see an x, we can collect them all together. Anywhere where we see a constant, so without an x, we can bring them together as well. So starting with the x's, we've got 1x plus 5x plus 7x plus 5x. Adding that up, that gives us 18x. And then for the constants, we've got minus 3, minus 3. So that's going to be minus 6. Fantastic. Now we're going to move on to the rectangle. Now look up at the diagram, we can see that we don't actually have a length for these 2 sides. However, using the properties of a rectangle, we know that this length is the same as this, and this length is the same as this. So I can actually write those on now so we don't forget. So that side is 4x, and this is 3x plus 4. So we've got all the information we need to work out the perimeter. So in the same way as before, we're going to add it all up. So we've got 3x plus 4 plus 4x plus 3x plus 4 plus 4x. And again, like we did last time, we're going to collect like terms. So we've got 3x plus 4x plus 3x plus 4x. So that gives us 14x
And now the constants, we've got 4 plus 4, so it's going to be plus 8. Now we're told that the two shapes have the same perimeter. Therefore, what we can do is we can say, well, that's going to mean both of these are equal because both the perimeters are the same. So we can say 18x minus 6 equals 14x plus 8. So now what we've got is an equation that we can solve. Okay, so the first step I'm going to do is I'm going to add 6 to both sides. I add 6 here and add 6 here. That gives us 18x equals 14x. And 8 plus 6 is 14. So plus 14. Now I'm going to subtract 14x from both sides. On the left hand side we're going to be left with 4x. On the right hand side we're going to have no x's left and just 14. Now finally, to solve the equation we need to get x by itself. I'm going to divide both sides by 4. So that gives us x equals, I'm going to write it as a fraction, so we've got 14 divided by 4. If we put that into the calculator, we'll get that that is equal to 3.5. Now we can move on to answering the question. And the question says we need to work out the area of the rectangle. Now for a rectangle, we've got an equation for the area. So the area equals the length multiplied by width. And what it means by this is, so this side here is the length, and this side here is the width. So we've got to do 4x multiplied by 3x plus 4. What's fantastic is in the previous bit of work, we worked out that x equals 3.5. So we're going to replace x with 3.5. So hopefully you'll see what I mean in a minute. We're going to have the area equals length, which is 3, multiplied by x, but I'm going to replace that with 3.5 plus 4. And that's going to be multiplied by the width, 4 multiplied by 3.5. So I'm going to work that out step by step. So first we're going to work out what's inside both these brackets. So 3 multiplied by 3.5 is 10.5. And we've still got plus 4 here. That's multiplied by 4 multiplied by 3.5, 14. Now this bracket first, we've got 10.5 plus 4, which is 14.5. And that's multiplied by this bracket here, so 14. And putting that into the calculator, we get the final answer of 203. Remember, because it's an area and we know all the lengths are in centimetres, we can put the units as centimetres squared. So last but not least, we're going to write that in the answer box. 203 centimetres squared. So we get the first mark for doing our working to work out the perimeters like this. So realising we have to add up all the sides. We get the second mark here for realising, because the perimeters are the same, we can set them both equal to each other. We get our third mark for then solving this equation to get x equals 3.5. We get a fourth mark for starting to work out the area and realising that we can replace x with 3.5. And we get the last mark for the correct answer of 203. Katie invests £2,000 in a savings account for 3 years. This account pays compound interest at an annual rate of 2.5% for the first year and X% for the second and third years. There is a total amount of £2,124.46 in the savings account at the end of the 3 years. And part A says we need to work out the rate of interest in the second year. So now I've written down here a definition for compound interest. So my definition is that you earn interest on both the money you have saved and the interest you earn. So essentially, using Katie's investment up here as an example, with compound interest, originally Katie invests £2,000. So for the first year, the 2.5% interest is applied to the £2,000. But because of the interest at the end of the year, Katie's going to have more money. So then for the second year, all of that money is essentially put back in the pot. And this interest is applied to all of the money, so the £2,000 and the interest earned in the previous year. This is different to the other type of interest you come across in GCSE Maths, which is simple interest, when each year the interest is only applied to the original amount, so it would only be applied to the £2,000 here. Okay, so I'm going to do this year by year. I'm going to start off looking at year 1. So it says in the question that Katie starts off with £2,000. In the first year, there's an interest of 2.5%. So we need to increase this by 2.5%. So to do that, we times by 1.025. And you might just know that that's what we need to multiply by when you're given a percentage. However, there's a little formula that we can use to work that out. So we can do 1 plus the percentage, so in this case 2.5, divided by 100. So that's how I got from the percentage to the number I need to multiply. And this sort of little formula thing is really useful, and we're going to come back to it in a minute. Okay, so putting this into the calculator,
we get that at the end of the first year, Katie's going to have £2,050. Great, so we're now going to move on to year 2. So in year 2, and remember, because it's compound interest, all of this money is going to be the starting point. So you're going to feed that back in starting with £2,050. And we're told there is an interest of X%. But obviously we don't know what that is at the minute, but we're going to write it in using this sort of formula thing. So we're going to multiply by 1 plus the percentage, so in this case it's X, divided by 100. And we're going to remember these brackets here because we're multiplying all of this by this. Okay, great. I'm now going to move on to year 3. So in year 3, all of this is going to be our starting point. So we're going to start with that. We've got 2,050 multiplied by 1 plus X over 100. So that's our starting point. And then we're told up in the question, again, it's X% interest for the third year. So the same as last time, on top of our starting point here, we're going to multiply that by 1 plus our interest, so X% over 100. Okay, so now we need to work with this to find out what X is. And the way to do that, we need to make an equation. And luckily, if we look back into the question, we see that the total amount of £2,124.46 is in the savings account at the end of the 3 years. So I'm going to do up here, I'm going to write out an equation using that. So we're going to say our 2,050 multiplied by 1 plus X over 100, multiply again by 1 plus X over 100, equals what we were told in the question. So 2,124.46. And one thing I notice here is we've got two terms that are identical and we're multiplying them together. We can actually write that as a single term squared. So to write this a bit more simply, I'm going to rub this out. I'm going to write that. It means the exact same thing, but I'm going to write it as 1 plus X over 100 squared because we're multiplying by it twice. Okay, great. So now what we need to do is solve this to work out what X is. So I'm going to start by dividing both sides by 2,050, which is going to leave us with 1 plus X over 100 squared. And using the calculator, we get that this is going to be 1.0363 ... But I'm going to leave the full long number stored in the calculator so we can keep on using it. I'm then going to square root both sides. So on the left hand side, I'm left with 1 plus X over 100 equals the square root of 1.0363 ... So I'm going to put that into the calculator and we get that is 1.01799 ... So now if I subtract 1 from both sides, we get that X over 100 equals 0.01799 ... And multiplying both sides by 100, we get that X equals 1.799 ... which equals 1.8 if we round to one decimal place. And there we've got the answer because the question asks us to work out the interest in the second year. And the interest is X%. So we've worked out what X is. So therefore, our answer down here is that the interest in the second year is 1.8%. We get 1 mark up here for the first year calculations. We get a second mark for going through the process and forming an equation like this. We get another mark for going through the process to solve for X. And we get our final mark for the correct answer of 1.8%. However, something to point out with this question, because it's not specific of how you should round it, we get the final mark for any answer between 1.79% and 1.8%. So in this case, I've gone for 1.8%. Katie goes to work by train. The cost of her weekly train ticket increases by 12.5% to £225. Part B says we need to work out the cost of our weekly train ticket before this increase. Right, so firstly, I'm going to let C, so the variable C, so that could be any letter, I've just called it C, be the cost before the increase. So we're going to create an equation that we can solve for this. So the cost before the increase is C, and that's what we want to work out. Then we're told that that increases by 12.5%. And we can use our little handy formula thing up here to work out what we need to multiply that by. So we're going to multiply by 1 plus, and because we're increasing by 12.5%, I'm going to put 12.5 up here, divided by 100. And we're told that after the increase, the cost is 225. So that will equal 225. Now we need to solve for C. So I'm firstly going to work out what's in this bracket. So we're going to have C multiplied by 1.125. And that's again equal to 225. Then if I divide both sides by 1.125, we're left with C on the left hand side and that's going to equal 200. And that's the answer to the question. Before the increase, the cost of the train ticket was £200. So you get 1 mark here if you're working out. So for dividing 225 by 1.125, then you get the second mark for the correct answer of 200. S and T are points on the circumference of the circle, which has centre O. P to T is tangent to the circle, and SOP is a straight line. Angle OPT is 32 degrees. Use this information, we need to work out the size of the angle marked X, and we must give a reason for each stage of our working. Okay, so questions like these can look quite daunting at the start because there's a lot going on. However, normally once you found the first bit of information, then the next bit will follow, the next bit will follow, so it all follows on quite logically. So the hardest part is finding the first bit of information. So we're going to have a look at what we've got. So we've got a circle here, and we've got a triangle here, and then we've got another triangle here. So we've got some triangles going on. We've been given this angle here of 32 degrees. However, there's another angle we can find out quickly, and that is OTP here. It looks like, look at the diagram, that it's 90 degrees. Well, we want to check that just to be sure. So in the question it says PT is tangent to the circle. We also know, because this is the centre of the circle, this sign here must be the radius. And whenever we've got a tangent and a radius meeting like this, we know that it must be 90 degrees. So we've proven that there, and I'm going to draw in this symbol to represent on the diagram that's 90 degrees. Also says we need to give a reason for each stage of our working, so I'm just going to write something down here. So essentially what we use here is one of our circle theorems, and I've written this down here just to summarise it, saying the tangents and radius always meet at 90 degrees. And because we've got that here, this means that the angle PTO is definitely 90 degrees. Okay, cool, so we've got our first bit of information, now the rest can follow on. So something else that we know is that the interior angles of a triangle add to 180 degrees. And we've got quite a few triangles up here. The one I'm going to look at is here, so we've got TOP, this triangle here. And we've got two of the angles, we've got 32 degrees here and 90 degrees here. And because we know all of the angles will add to 180 degrees, we can work out this one here. So from that, okay, so I'm going to say 180. I'm going to subtract from that the angles we know, so minus 32 and minus 90. We're going to see what we get, and we get 58. So that means we know that this angle here is going to have to be 58 because all of these angles added together need to make 180. And I'm going to draw that onto the diagram here as well, so remember it. So here we've got 58 degrees. Cool, so we've got another bit of information. Now I'm going to have a look again. So I'm going to focus around here. We know that angles at a point on a straight line, so here, add up to 180 degrees. So all of this is 180 degrees. And because we've got this part here, we can work out what this angle is here. So again, I've written that here, giving our reasoning like it asked us to do. So angles at a point on a straight line add to 180 degrees. So we're going to do 180, subtracting what we know, which is the 58, gives us 122. So angle is 122 degrees. And again, I'm going to draw that on the diagram so I remember. So this angle here is 122 degrees. So hopefully you can see how we'll work our way through it with each bit of information leading on to the next step. Now I'm going to focus in on this triangle here. And we see that O to T here and O to S are both the radius of the circle, because again, O is the centre. So we know that O to T and O to S must be the same length. So therefore we've got an isosceles triangle here, because an isosceles triangle is a triangle with two sides of exactly the same length. So I've written that here, that OS and OT are both the radius, so are the same length, meaning that this triangle here must be isosceles. Now I'm just going to draw out here an isosceles triangle so we can visualize this. So this is an isosceles triangle because this length and this length are the same. And what we then know about isosceles triangles is that this angle here I'm going to call it A, and this angle here I'm also going to call it A because they're both the same. And then we've got another angle here, I'm going to call it B, which is a different size. So we know that these two angles are the same. So applying that up to the diagram we've got here, because these two sides are the same length, we've got this angle of X here, we know that this angle here is also going to be X. So therefore angle TSO is X. So essentially this is what we've got now. I'm going to draw it out. So we've got this angle being X, this angle being X, and this angle we know is 122 degrees because we worked that out in our previous step. Now this is great, we've got all the information we need to work out what x is, because interior angles of a triangle add to 180 degrees. So we know that x plus 122, which we got in this case here, is 180 degrees. Now we've got an equation we can solve. So combining these x's together, we're going to have 2x plus 122 equals 180. Subtracting 122 from both sides, we get that 2x equals 58. And dividing both sides by 2, we get x by itself equals 29. And we're going to put our little degrees there and remember that. So our answer to the question is that x equals 29 degrees. So we got our first mark by working out that this angle here is 90 degrees. We got our second mark here for working out this angle is 58 degrees. And we get our third mark for actually working out what x is. So going through all the working and getting down to x being 29 degrees. And then we got our fourth mark for our reasoning. So all of this that we've written down, all our thoughts throughout the question, we get a mark for that. A and B are two sets of traffic lights on a road. The probability that a car is stopped by light A is 0.4. If a car is stopped by light A, then the probability that the car is not stopped by light B is 0.7. If the car is not stopped by lights A, then the probability that the car is not stopped by B is 0.2. So we need to complete the probability tree diagram for this information. Okay, so that's a lot of information there, so we're going to break it down. And luckily they've given us this tree diagram here already to help us. So here we've got our information for lights A, and here for lights B. So we're going to go through the question line by line. So probability that a car is stopped by lights A is 0.4. Okay, so on the tree diagram, we've got lights A here, and here's stop. So here's where we're going to put the probability. So the probability the car is stopped by lights A is 0.4. So that goes on this branch of the tree. Okay, so next line. If a car is stopped by lights A, then the probability the car is not stopped by B is 0.7. So the car's been stopped by lights A, so we've gone down this part of the tree, and then it's not stopped by lights B. So we then go down this part of the tree to not stopped. So we're going to be putting our probability here. And in the question we're told that's 0.7, so I'm going to put that in here. So you've done that one now. So if a car is not stopped by lights A, so we're going down this path, then the probability the car is not stopped by B is 0.2. So we've gone down this path, and then it's not stopped by B either, so we've gone down this path. So we're going to put our probability here, and that's going to be 0.2 as it says in the question. Great, so we've got all our information from the question, so now we need to work out these three other probabilities. So I've written here that the sum of probabilities is 1. And what I mean by that, so I'm going to have an example here, is that the probability of either getting stopped by lights A or not stopped by lights A is 1. So that's definitely going to happen. You're either going to get stopped by lights A or not stopped by lights A. There's no other option. So there's a 100% chance of one of these things happening. Therefore, these probabilities need to add up to 1. So to work this out, we're going to do 1 minus 0.4, which gives us 0.6. So in here, we're going to put 0.6. Now, it's the exact same logic over here. So look at this part here. Again, the probability of being stopped or not stopped is going to happen. One of those, they're the only two options. So they're going to have to add up to 1. So we've got 0.7. So it's going to be 1 minus 0.7, which equals 0.3. Just going to put that in there. And the same thing for here. Both the probabilities are going to add up to 1. So you've got 1 minus 0.2, which equals 0.8. It's going to pop that in here. Fab, so we're all done with part A. And we get 1 mark for correctly putting all the answers in light A. And we get 1 mark for correctly putting all the answers in lights B. So now moving on to the next part. Mark drove along this road. He was stopped by just one of the sets of traffic lights. Is it more likely that he was stopped by lights A or lights B? You must show your working. So the key here is he was stopped by just one set of traffic lights. So we're going to look at the diagram to see what the possibilities are. So he could have been stopped by light A, but then he can't have been stopped by light B. He's going to have to be stopped by light A and not stopped by light B. Or he was not stopped by light A, but then he was stopped by light B. So there are these two possibilities. This route through the tree, or this route through the tree. Now I've just written this thing down here saying for and we multiply. And hopefully you'll see what I mean in a minute with that. So we're going to look at the two options. We've got the probability of being stopped by lights A and not stopped by lights B equals. So we've got the probability of being stopped by lights A, which is 0.4. And this is the key here, it's and here I said we use multiply for and. So essentially what that means is we're going to multiply the probabilities together. We've got the probability of being stopped by lights A and the probability of not being stopped by lights B, which is 0.7. So we're going to multiply 0.7. So working that out in the calculator, we get 0.28. So that's our probability for that option. So now we've got the second option. We've got the probability not stopped by lights A and stopped by lights B. So again, we've got our and in there, so we're going to be using multiplication. We're going to have a look at the probabilities. So we've got not stopped by A, so that's 0.6, and stopped by B, so that's 0.8. So we've got 0.6 multiplied by 0.8, which gives us 0.48. Great, so we've now evaluated both our options. So now we've got to answer the question, is it more likely that he was stopped by lights A or lights B? Well, for the first option, he was stopped by lights A, and for the second option, he was stopped by lights B. And the probability for the second option is 0.48 is greater than the probability of the first option, 0.28. So being stopped by lights B is more likely. So in this part of the question, we get 1 mark here for multiplying our probabilities together. We got a second mark for getting the correct results here. We got a third mark for a correct conclusion by comparing the probabilities. D is inversely proportional to C. When C is 280, D is 25. You need to find the value of D when C is 350. Okay, so I'm going to write it out like this. We've got D is inversely proportionate to C. So that's what this is a mathematical way of writing it. So what we've written here mathematically is D is inversely proportional to C. So next step, what we do is we create an equation using a constant of proportionality, which we introduce. So what we do is we take D here, we make an equation by saying equals, and we multiply by a constant. In this case, we're going to call it K. So K multiplied by, again, what we had up here, so 1 over C. So here is our constant of proportionality. Now, we need to know what this constant is, because this is a certain value, but we don't know what it is at the minute, so we just said K. We're going to do that using the information up here, that we know that D is inversely proportionate to C when C is 280 and D is 25. So we're going to sub in the info from the question. So that's saying D is 25. I'm going to keep K the same because that's what I want to find out. So K multiplied by 1 over, and C is 280. So we'll write that again. So we've got 25 equals, and working this out, it will be K over 280. Now if we multiply both sides by 280, we get 25 multiplied by 280 equals K multiplied by 280 over 280. We can see these on the top and bottom here, they're going to cancel. So what we're left with is K equals 25 times 280, which is 7,000. So that's great, we've worked out what our constant of proportionality is. Now we're going to use this to create a general equation linking C and D. So because we now know what K is, and we know up here that D equals K multiplied by 1 over C, we can say, okay, so we've got D equals, and I'm going to write it a bit like this way here. I'm going to say K, so 7,000 over C. So now we've created a link between C and D using our constant and proportionality here. So now we get to the final part of the question, which is find the value of D when C is 350. So we're going to sub C is 350. And then we'll have a value for D. So we'll have D is 7,000 divided by 350, which is 20. So our answer here is that D is 20. So we get 1 mark here for creating our link between D and C and subbing in these values with our constant here, so K. We get our second mark over here. So for finding out that K is 7,000 and substituting C equals 350 to create this here. Then we get a final mark that through all of that, we work out the correct answer of D being 20. So this question says we need to prove algebraically that 2n plus 1 all squared minus 2n plus 1 is an even number for all positive integer values of n. Okay, so I'm going to write out what we've got here. So we've got 2n plus 1 squared subtracting 2n plus 1. Now what does that equal? So what we're going to do is we're going to expand this out and see what we get. So we're going to expand these brackets first. So we're going to have 2n plus 1. I'm going to write it out as 2 sets of brackets because we know when we've got something squared, that's the same as timesing 2 things that are the same together. So we've got 2n plus 1 times again 2n plus 1. And again, we still got this minus 2n plus 1 at the end. Okay, so now to multiply these brackets, we need to multiply every element with each other. Now I like to use a method called FOIL. And this stands for front, outside, inside, last. And you'll see what I mean in a minute. But we're going to use this to remember every combination. So we start with front. So we multiply together both of the starting elements. So we're going to have 2n multiplied by 2n. We're going to add on to that. So now I'm going to do outside. So here we're going to do the front element and the last element here. So the outside elements. So we've got 2n multiplied by 1. So we're going to add on to that. We've now going to be looking at the inside elements. So the 1 here and the 2n here. So multiplying that together, we got 1 multiplied by 2n. And lastly, the L, so the last elements. So 1 and 1. So plus 1 times 1. And again, we still got this minus 2n plus 1 here. Brilliant. So now I'm going to tidy this up a bit. So this bracket, 2n multiplied by 2n, is 4n squared. So we've got the 2 times 2 is 4, n times n is n squared. So in this bracket we got 2n, and this bracket we got 2n, and we're adding them together. So that's going to give us 4n, and this final bracket is 1 times 1, so it's going to be 1. I'm going to subtract from that here our 2n minus 1. Okay, so we've got 4n squared plus 4n plus 1. And we're subtracting all of this in brackets. So essentially what this means is I'm going to write something out here. We're going to have plus minus 1 times by this. That's essentially what it means. So we're going to have plus. If we do minus 1 times this bracket, we're going to multiply each element in the bracket by minus 1. So 2 times minus 1 is going to be minus 2n. And sorry, here it's actually supposed to be plus because I copied it down wrong. So we can see here it's plus 1 and plus 1. So we're going to have minus 1 multiplied by positive 1, which is negative 1. So we have that here. So if I write that out neatly, we got 4n squared plus 4n plus 1 minus 2n minus 1. So I'm going to collect like terms together. So essentially that means we've got a 4n here and a minus 2n here. So we can collect them together. We can have 4n minus 2n, leaving us with positive 2n. And then we've got our constants here. So we've got 1 and minus 1. So combining them together, doing 1 minus 1, we get 0. So we're left with this. Hey, so that's brilliant because we have got down from this, which looks really quite complicated. We expanded it out and simplified it to get down to this, which is much easier to work with. So I'm going to use this to show that it's always an even number. So I'm just going to have a think about properties of even numbers. So I'm going to write some out. We've got 2, 4, 6, 8, 10. And now we know that all even numbers are divisible by 2. That's what makes them even, which means every even number can be written as 2 multiplied by something. So here we've got 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. Essentially, what I'm showing here through some examples of even numbers is that even numbers are divisible by 2. So a fancy way of saying that is that all even numbers have a factor of 2. So essentially they can be written as 2 multiplied by something. So we're going to use this fact for showing that this is always even. So we've got 4n squared plus 2m. And we see that both these here, the coefficients are even, so we've got 4 and 2. So we can take out a factor of 2. So I can write 2. Then in brackets, we're going to be left with 2n squared plus n. We see this is true because if we go the other way and multiply the 2 into the brackets, we're going to have 4n squared and 2n. So we can do this. So essentially we've shown that it's always even because we've written it as 2 multiplied by something. So I'm just going to write a bit of a conclusion to the proof. So since 2 is a factor, which we've shown here, it is even for all positive integer values of n. And we completed the proof there. So we get 1 mark for correctly starting to go through the process of expanding the brackets. We get our 2nd mark for getting through that process correctly and getting down to 4n squared plus 2m. We get our 3rd mark for a convincing conclusion. So in this case, showing that 2 is a factor and explaining that here. So we're going to take a look at this question that says, prove algebraically that the recurring decimal 0.25 recurring has a value 23 over 90. So the fraction here, 23 over 90. Okay, so whenever you get a question like this, the first step is to set this number here, so the recurring decimal, to a variable. So we're going to say x. We're going to use the variable x and say x equals 0.25 recurring. Now, just to be clear what we mean by this, is recurring just means it keeps on going on. So we've got this little dot above the 5. So that means the 5 keeps going. So it's 0.25, 5, 5, 5, 5, dot, 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 and keeps on going like that. And to represent that it keeps on going, instead of writing loads of 5s out, we just put a dot above the number that keeps on going. So in this point, the 5. So to be able to write it as a fraction like this, we've got to find a way to sort of eliminate this recurring part. And we use a bit of a trick to do that. So if we got x here, what I'm now going to do is I'm going to write 10x. So we're going to multiply both sides by 10. So multiplying this side by 10, we get 10x. Now we've got to multiply this side by 10. So that will give us 2.5555 recurring. So the 5 just keeps on going. So essentially, whenever you get a question like this, your goal is to isolate the recurring part to the right of the decimal point. So in this case, we times by 10, which meant on the right hand side of the decimal point is just the recurring part. So hopefully that makes sense, and we'll see why we do that in a second. So the next step is we're going to take 10x and we're going to subtract x from that. So we're going to do 10x, subtract x, and that gives us 9x. So we're going to go down here and actually carry out the operation. So we know that 10x is 2.5555, so on. And x is 0.2555, and so on. So we're going to carry out the operation here, so subtracting it. So if you subtract all these 5s from all these 5s, just get a 0. Same here, 0, 0. We're going to take 2 away from 5 to get 3. And we're going to put the decimal point in the same place. We're left with 2, take away 0, and we're left with 2. So from this, I can say, okay, so now I know that 9x is what we just worked out here. So 2.3. And we've done what we need to. We've got rid of the recurring part. So this is just 2.3, and it stops. We don't have any numbers in it, like up here with the 5. It keeps on going on and on and on forever. So now we need to get back to what we were originally talking about. So our original number up here, we represented with an x. So we need to get back to that state, really. So what we're going to do is divide both sides by 9. We're going to have x equals 2.3 divided by 9. So now we're back to our original number. We're back to x. Now, to get this into a bit of a nicer form, we're going to times the top by 10 and times the bottom by 10. Because remember, anything you do to the top of the fraction, you've got to do to the bottom of the fraction. And in doing that, we get that x equals 23 over 90. And that's fab, because if we look back up the question, that's what we needed to show. We get 1 mark for this working up here. So essentially setting our recurring decimal to a variable and work out what number we need to times that by to be able to subtract them to get down to a number that isn't reoccurring. And then we get our second mark for having gone through that process and getting to the correct answer that we need to show over 23 over 90. Show that 1 over 6x squared plus 7x minus 5x divided by 1 over 4x squared minus 1 simplifies into the form ax plus b over cx plus d, where a, b, c and d are integers. Okay, so in questions like this where we've got simplify and we've got some quadratics, what you quite often have to do is factorise the quadratics. And what that essentially means is put it into brackets. So hopefully you'll see what I mean in a minute. I'm going to start off with this expression here. So we're going to factorise 6x squared plus 7x minus 5. And I'm going to show you a little trick you can do with this. So they're a little bit more tricky when we have a coefficient here in front of the x squared which isn't 1. So whenever you've got that, you can use this little trick. So the first thing we have to do is we multiply the coefficient of x squared by the constant here at the end. So in this case, we're going to take the 6 and multiply it by minus 5. So I'm going to do that here, 6 multiplied by minus 5. And that's going to give us minus 30. We now need to find a set of two numbers that when you multiply them together, make this number here. So minus 30 in this case. And when you add them together, create this number here. So the coefficient of x, so in this case 7. So in this case, the two numbers that will work are 10 and minus 3. Because if we do 10 multiplied by minus 3, we get minus 30. So that's perfect. And if we do 10 plus minus 3, so essentially just 10 minus 3, we get 7, which is perfect. So those work. So our numbers are 10 and minus 3 in this case. Then the next step is we write out our brackets and we look up and we see, okay, so we've got 6x squared here. So in each of these brackets, I'm going to put 6x and I'm going to fill the other end with the numbers. So we got plus 10 and minus 3. And the next step is we need to look and try and simplify the brackets. So what I mean by that, I'm going to have a look at the first bracket first. And can see I can divide both by 2. So if I do that, I'll get 3x here plus 5. And I can't simplify that anymore. So we're good with that. Now we're going to do that with the other bracket here. I can see I can divide both by 3. So I'm left with 2x and minus 1 here. And that there is the fully factorised form. Brilliant. So now I'm going to look at the other quadratic. So we've got 4x squared minus 1. Now this one's a bit different. This is a special form of quadratic called the difference of two squares. So basically what that means is you can do this. So if you've got something in the form a squared minus b squared, its factorised form is a plus b, a minus b. And we have that here. This is actually an example of difference of two squares. And I'll show you how. So if we take the first term here, I can rewrite that as 2x all squared. And look at our second term, we've got minus 1 all squared. So if we look up here, okay, so our a is 2x and our b is 1. So factorising this, we're going to get 2x plus 1, 2x minus 1. It's great, so this is the factorisation of that quadratic. So now we factorise them, we've got that here, we can go about answering the question. So we're going to write out the question, replacing the quadratic with the factorised form. So this is what we get here, this is what we're now trying to work out. And we can use this rule here. If we have a over b as a fraction, for example, divided by c over d, that equals a over b multiplied by d over c, which equals ad over bc. So essentially the rule is that when you're dividing by a fraction, you flip this fraction over and then multiply them. So doing that to this, we're going to be left with 2x plus 1 multiplied by 2x minus 1 on the top, all divided by 3x plus 5 on the bottom, and 2x minus 1 on the bottom, like that. Now what we can now see, we've got a common factor on the top and the bottom of the fraction. So we can cancel it down. So we can cancel this bracket and this bracket like this. So we're going to be left with 2x plus 1 all over 3x plus 5. And that is the answer to this question. We got it in the form ax plus b over cx plus d. So a is 2, b is 1, c is 3, and d is 5. And in this 3-mark question, you get 1 mark for getting either of these factorizations correct. You get another mark for this part here. So realizing you can use the rule to flip the second fraction over, take its reciprocal, and multiply them together. And you get the third and final mark for the correct answer down here. The diagram shows a sector of a circle with radius 7 centimeters. We need to work out the length of the arc AB, giving our answer correct 3 significant figures. Okay, so I've drawn on here, the length of arc A to B is this side here, so we're working out this length here. So to do that, we're going to take a step back. Instead of just thinking about this sector, we're going to think about the whole circle. So I've drawn that out here. We've got a whole circle, again with the same radius of 7 centimeters. So the whole circumference of the circle, we can work out with this formula. The circumference is pi multiplied by the diameter. Now the diameter is 2 times the radius. So the diameter is this whole length here. So I've got the diameter 2 multiplied by the radius, which in this case is 2 multiplied by 7. So it's going to be 14 centimeters in this case for the circle. So we're going to have the circumference is pi multiplied by that. So pi multiplied by 14. So I'm going to leave that here as 14 pi for the minute. And we can work that out in the calculator in a second. Okay, so this is the size, 14 pi, of the whole circumference. We don't want that. We just want this section here, A to B. Now we know that this section here is, this angle here is 40 degrees. So we know the whole angle here. So in a circle, this whole angle is 360 degrees. So we've only got 40 degrees of it. What we've got, I'm going to write it down here. We've got 40 out of 360 multiplied by the circumference, because this A to B length here is 40 over 360th of the entire circumference. So we can work out using this. So I'm going to do that, and I'm going to put that into the calculator. So that gives us 4.886921906. And in the question, it wants that to 3 significant figures. So that's going to be 4.89 if we round it to 3 significant figures. So here, 4.89, and we need to remember the unit, and it's given it to us here of centimeters. And marks wise, we get 1 for writing out this here, and we get the second and final mark for the correct answer. So we got this statement here. We got that m equals the square root of s divided by t. We're told that s is 3.47, correct to 3 significant figures, and t is 8.132, correct to 4 significant figures. And by considering the bounds of these, we need to work out the value of m to a suitable degree of accuracy, giving a reason for our answer. Okay, so we're going to start by working out the bounds. I'm going to look at s first. And we're told that 3 significant figures, s is 3.47. So we need to think about, okay, so what could have the actual value of s been originally, so that when it was rounded to 3 significant figures, we got this. And what we think about that, we think about the lower bound it could be, and the upper bound. So lower bound for that would be 3.465. So if you think about that, if you round that to 3 significant figures, you get 3.47, which is what we need. Remember, anything less than this value, so if let's say we had 3.46499999, carry on. When you round that to 3 significant figures, you'd actually get 3.46. So because of that, we know that this got to be the lower bound. So I'm going to draw in this symbol. So you can see I've said that s is greater than or equal to. So if it's equal to this value, we go to 3 significant figures, we get the value we want, or greater than that, we'll get the value we want. Now we need to look at the other end. What's the upper bound? So the highest value it could equal, and still around 3.47 and 3 significant figures, will be 3.474999, and that just keeps on going. Because if you think about that, any higher than that, if we had 3.475 and I round that to three significant figures, that would give us 3.48, which isn't what we want. So this is the highest value we could have. And this works, but it's not very neat writing it like this. What we actually do is we write this as 3.475 and change the symbol here from less than or equal to just less than. And that means the same thing. That's great. So we've worked out the bounds of S. Now I'm going to do the same with T. So it's the exact same process as with S. However, this time we're looking at something for four significant figures. So you've got 8.132. So the lower bound for that would be 8.1315. So if we go any lower than that and round it to four significant figures, we get 8.131. So this is the lowest value that would round to 8.132. And again, for the upper value, that would be 8.1325. And we've still got the sign as less than and not less than equal to, because if we actually had this value, it would round to 8.133, which is not what we want. So it needs to be strictly less than. Great, so here we've done our work working out our bounds. Now we're going to do the second part of the question where it says we need to consider these bounds and work out the value of m to a suitable degree of accuracy. Now m here is defined as a fraction, so I've written something over here that's going to help us. So it said if x is a big number divided by a small number, x will be a big number. It'll be quite a large number. But if x is a small number divided by a big number, then x will be a really small number. And you could try some values out in your calculator and see, and hopefully that makes sense. So we're going to use this fact with the bounds to try and work out the highest possible value for m and the lowest possible value for m. So the lower bound for m, we're going to have the square root of s over t. But we need to think about which value we pick for s and which we pick for t. But because you want the lower bound, so we want the small number. So if we think about the fraction, we want a small number on the top and a big number on the bottom. Well, the smallest possible value we can have on the top is this one, 3.465. So we're going to put that in there. We want a big number on the bottom, and the biggest number we could have here is 8.1325. And we're going to do the same for the upper bound of m. So using the same logic, to get the biggest possible number for m, we want the biggest possible number on top. So that's going to be 3.475. And the smallest possible number on the bottom, so it's going to be 8.1315. What we do is pop those into the calculator to see what we get. So now to see what value we're going to give m to a suitable degree of accuracy. So to do that, we're going to look for the highest degree of accuracy when the upper bound and lower bound round to the same number. So if we look at both these numbers here, so we can round them to one decimal place and they both get to 0.2. Two decimal places, they both get to 0.2. Three decimal places, okay, so we get 0.229 and 0.229, so that's the same thing. If we go to four decimal places, this would be 0.2289, and this would be 0.2292. So at four decimal places, the values would be different, but at three decimal places, they're the same. So that's the highest accuracy where the upper and lower bound round to the same number. So in this case, we're rounding to three decimal places, and we're getting the value of m to be 0.229. And it says we need to give a reason for our answer. So give a reason why we've concluded that m is 0.229. And the reason for that is what we've just been talking about, since both the lower bound and upper bound round to 0.229. So we get our first mark for trying to work out these bounds here. We got a second mark for realising we need to sub a combination of the upper and lower bounds into the equation. And we get another mark for this part as well, for choosing the right combination to sub in to get the lower bound and upper bound. We get another mark for getting the correct values here. Then we get the final mark for our answer of 0.229 and our reasoning for that. The graph of y equals f of x is shown on both the grids below, so we can see that here. And part A says, on the grid above, we need to sketch the graph of y equals f of minus x. So what I've written here is that this means a reflection of the y-axis. And if you think about it, that sort of makes sense, because any x value, when negating it, times it by minus 1. So for example, this minus 2 here, if you times it by minus 1, you get 2. And sort of, you could think about that, okay, so that's reflecting it in the y-axis. So it makes logical sense. So yes, you just need to remember that that's a reflection in the y-axis. So we're going to carry that out now. So we're going to do a sketch above. So reflecting the y-axis, and we start with this point here. That's going to be the same. I'm then going to think about this point that we talked about, -2. So it's going to go over to 2 here. This point here is going to go over here. So I'm just sort of labeling on the points that are easy to, that line up well with the grid. Then this one is going to go over here. And this one is going to go, so we've got 1, 2, 3, 4. 1, 2, 3, 4 over here. And so we've got some points here. We've got the general shape. And because it's a sketch, it doesn't have to be perfect. We'll give it our best shot. We're going to go down through these points and up like that. Fab. So now we've done that, we're going to move on to part B, which is a similar question. It says, on this grid, sketch the graph of y equals -f of x plus 3. And this is a little bit more complicated because it includes 2 different transformations. So firstly, we've got a reflection in the x-axis. So this time, the minus sign isn't inside the bracket there, it's outside. So instead of reflecting the y-axis, we're reflecting the x-axis. Then also the second part is a translation by vector 0, 3. So that's what this +3 means. A little reminder what this vector notation means. So it's laid out like this. The top number represents left, right, and the bottom number represents up, down. So in this case, we've got 0 on the top, so no left and right, and we've got 3 on the bottom, up and down. So therefore, we're going to translate up by 3. So again, like last time, I'm going to look at some points. So starting off with this one, if we reflect it in the x-axis, it's going to be the same point. And then up by 3, so 1, 2, 3. So there we go. So I'm going to mark a point on there. Just going to have a look at this one now. So if we reflect in the x-axis, we're down to here, and up by 3, 1, 2, 3. So we're in this point here. The same with this one. That's going to end up in the same position down there and up to here. And I'm going to look at this point. We're going to reflect that down and up 1, 2, 3. And this one is going to end up going up to here. Now I'm going to roughly try and sketch the curve now. So we're going to go down here like that. And it will carry on this side as well, doing the same thing. And then bro, so we just get 1 mark for a correct sketch up here. And we get another mark for this one here. When you solve algebraically the simultaneous equations here. Now there are a few different methods for solving simultaneous equations. However, for this one we're going to use the substitution method because we've got something squared here. So the substitution method would be the best method here. Essentially our first goal is to eliminate one of the variables. Because to solve an equation we need equation just to have x in it or just to have y in it. So the first step here is to do that. And how I'm going to do that, I'm going to take the second equation here. I'm going to rearrange it. So if we add 2x both sides, we get y equals 5 plus 2x, or I'm going to write it as 2x plus 5, like that. So now what I'm going to do from that, I'm going to sub this value of y, 2x plus 5, into this equation at the top, eliminating the y. So you'll see how that works in a second. So we've got x squared plus 2x plus 5 all squared equals 25. So now this is great. We've got our first step ready. We've eliminated the y. And we've just got a single variable, x. Now we can solve the equation for x. So I'm just going to keep this x squared here, and I'm going to expand out this bracket. So doing that, if I write it out as 2 brackets, it might be easier to see. But we need to times every term by every other term. So if I multiply this term by this term, we get 4x squared. If I do this term and this term, we get 10x. Again, this term and this term, we get 10x as well. And last but not least, this term and this term, so we get just 25. Again, that equals 25. Now I'm going to tidy this up a bit and clean it up. So we can add these 2 terms together, giving us 5x squared. Add these terms together, we're going to get 20x. And then I'm going to leave the plus 25 here equals 25. Now we can do one more tidying up. We can do 5x squared plus 20x again. But if we subtract 25 from both sides, will just be left with equals to 0. So one more simplification thing we can see for the minute is we've got 5x here, 20x here, and 0 here. So we can divide every term by 5, leaving us with x squared plus 4x and equals 0, because 0 divided by anything is just 0. Great, so this is now our simplified equation. Now we're going to solve it. And to do that, I'm going to factorize out the x. So I'm going to take the outside of the bracket, and inside the bracket I'm left with x plus 4. Because we can see we can multiply this back in to get x squared plus 4x. And that still equals 0. So now solving this, for this to be true, either this term has to be 0 or this term has to be 0. So we could either have x plus 4 equals 0 or x equals 0. Well, for x equals 0, we've got a solution there. That's a value for x. And for this one, we need to rearrange it a bit more. If we subtract 4 from both sides, we'll get x equals negative 4. So again, that's the solution. So here are two values for x. So now we want to work out the corresponding y values. Now we could use either equation to do this. However, I'm going to use this second one because it's just a bit simpler. You always want to make your life as easy as possible when doing these questions. So we've got y minus 2x equals 5. So firstly, we're going to sub one of our values for x. We're going to start with x equals 0. So when x equals 0, we'll get y minus 2 multiplied by 0 equals 5. So we get y equals 5. So that's one of them there. And now our second one here, we're going to sub the other value for x. So when x equals minus 4, we get y minus 2 multiplied by minus 4 equals 5. Okay, so minus 2 multiplied by minus 4 is 8 equals 5, sorry. So then y equals 5 minus 8, which is minus 3. So now we've got our solutions, and I'm going to write them out neatly because we need to remember that we've got two pairs of solutions. So you need to make them clear that they're linked together. So we've got our solutions. We've got x equals 0, y equals 5, and our other set of solutions is when x equals minus 4, y equals minus 3. And that here is our solution to the simultaneous equations. So we got our first mark here for subbing in y equals 2x plus 5. So eliminating the y value to get an equation just in x. We then get a second mark for going through this process. So expanding and simplifying down to get a quadratic like this. Then get 1 mark for going through the process of solving that quadratic. Then another mark for the correct solutions. Then we get our final mark for the overall correct answer. So then using those solutions we worked out here to find the corresponding y values. And having the correct pairs here. So in triangle RPQ, we know that the length RP is 8.7 centimeters, PQ is 5.2 centimeters, and the angle PRQ is 32 degrees. And part A says, assuming that the angle PQR is an acute angle, calculate the area of triangle RPQ, giving your answer correct 3 significant figures. So just a reminder of what an acute angle is. So an angle is acute if the angle is less than 90 degrees. So it's less than a right angle. So we know that PQR is acute. We also know that the angle PRQ is acute because we've been told it is 32 degrees. So we start to draw a sort of rough sketch of the triangle to try and work out what we're doing. So I'm going to start with the point Q, and I'm going to draw R here. I'm going to join those up here. And this is where the fact that the angle PQR is acute comes in. We could either draw P somewhere up here or somewhere over here. If it was over here, as you can see, the angle would be obtuse, so it would be greater than 90 degrees. If it's over here, it's going to be less than 90 degrees, so acute. So we know we're going to have to draw it somewhere over here. So I'm going to draw it, if we go for here, and then I'm going to complete the triangle. So this side is P. And I'm going to fill in the information we know. So we know that the length R to P is 8.7 centimeters. P to Q is 5.2 centimeters. And the angle PRQ is 32 degrees. Great, so now we need to work out the area of this triangle. And for this, I think we can use the sine rule, which I've written out here. So the capital letters here represent the angles. And the little letters here represent the opposite side. So for example, if this was angle A, this would be side A. So what I can do using that is I can say, okay, so sine 32, so that's the angle we've been told, over, and if I look at the opposite side, that's 5.2 centimeters, equals, and I'm going to call this angle here, that we don't know, I'm going to call that x. So we say, okay, sine of x over, and the opposite side to that is 8.7. And now we've got an equation here that we created that we can solve. So if I multiply both sides by 8.7, we'll get sine x by itself. So I'm going to do 8.7 multiplied by 932 over 5.2. And to get x by itself, we need to do inverse sine of all of this. So 8.7 multiplied by sine 32 over 5.2. And if we put all of that into the calculator, we get 62 point, and I'm going to write out a few decimal places. So we got 44853188, and that's an angle. So we got degrees. Now our second step is we're going to work out angle P, and it's this remaining angle. And we can do that because we know all of the angles in a triangle add to 180 degrees. So we've got 2 of them, so we can work out the third one. So I'm going to label this one up here, angle, let's call it Y. So Y equals 180, because all of the angles add up to 180, minus 32, subtracting the other angle we just worked out, so 62.448 ... And it's good if you store this long number in your calculator, you can use it when you're doing this sum in the calculator to make it as accurate as possible. So that gives us that this angle is 85.55146812 degrees. So what we're going to do is use this formula for the area of a triangle, which says the area of a triangle is half AB multiplied by sine C. And if you think about it in this triangle here, we've got the angles ABC, and then the sides corresponding to that are the ones opposite to it. So to work out the area of this triangle, we would need this angle here, and the 2 sides that are connected to the angle. And if we think back to the question, we've got that now, because now we've managed to work out this angle here. We've got this angle and these 2 sides connected to it. So I've done a little sketch here of the triangle with all the information we need. So we've got an angle here and the 2 sides, so we can now work out the area. So the area is going to be half multiplied by these sides, so 5.2 multiplied by 8.7 and multiplied by sine of this angle. And I'm going to use the full number when I put it in the calculator, just to make it as accurate as possible. But just for writing, I'm going to do 85.6 here. So doing that, we get 22.55185522. And if I do that to 3 significant figures, that's 22.6 to 3 significant figures. So that's the answer to the question, 22.6. We need to remember centimetres squared. And looking to see where we get the marks for part A. So we get the first mark for starting the process of labelling the triangle and drawing it out like this, and realising we can use the sine rule like that. We get a second mark for doing this bit of working, so rearranging, so we get x equals sine inverse of this. We get the third mark then for going through this process down to here to calculate the area. We get the fourth mark for the correct area to 3 significant figures. Right, so now part B says, if you did not know that the angle PQR is acute, what effect would this have on your calculation of the area of the triangle RPQ? Okay, so I've got a little diagram of the triangle here, and in this case, Q is acute, you can see here. So as we said in the previous part, when the angle is acute, it means it's less than 90 degrees. So the other option would be that the angle could be obtuse or greater than 90 degrees. And I'm going to model what that could look like on this triangle here. So this angle is going to stay the exact same. The only thing that's going to change is this from acute to obtuse. So I'm going to change this angle. So if I made it obtuse, so bigger than 90 degrees, so I'm going to need to, it'll be something like that. And P will be up there. So this is the triangle when the angle is acute, and this is the triangle or an example of it when it's obtuse. So you see this angle stayed the same, but P has got much smaller up here, and Q has got bigger, so things have changed around. As you can see, the area of the triangle has also changed. So essentially what the question is getting at, if we didn't know that the angle was acute, so if we didn't know the triangle was this one, it could have been either of them. So what we need to do to get the mark for this question is just write out, we would need to work out the area of two triangles, and that would get you your mark. So you wouldn't need to draw these diagrams or anything, that was just to help explain. All you need to write is this bit of text here. This object is made by removing a small cone from a large cone as shown in this diagram. It's made from glass, and the glass has a density of 2.5 grams per centimetres cubed. And we need to work out the mass of the object, giving our answer to an appropriate degree of accuracy. Okay, so this is the object here, this part here. And as we can see in the diagram, what it describes in the question, it's made from taking a large cone and subtracting a smaller cone from it. So currently we've got lots of information for the large cone here, and we've got information for the final object, but we haven't got any information for the smaller cone. So that's what I need to work out first. So I'm going to abstract from this diagram. I'm actually going to make things easier. I'm actually going to look at a triangle. So we've got the larger triangle here and the smaller triangle here. Now we know from the diagram that the length of the whole larger triangle is 15 centimeters and the width is 12 centimeters. And the length of this portion here is 10 centimeters. So now from that we can work out this length here, and we can work out how long this is, and that's going to be 5 centimeters. And the reason for that is because we've done 15, because we know the whole length of it is 15. We've got 10 here, so we know this must be 5, because 15 take away 10 equals 5. Now what we can say is that these triangles are similar triangles. So this little one and the big one are similar triangles. Now if we think about this big triangle being 15, and this one being 5, I'm going to do 15 divided by 5. That's going to give us 3. So I can say therefore, I can then say that the big triangle is 3 times the size of the small triangle. Now I can use that fact to work out this length here. So we know the width of the big triangle is 12 centimeters. We also now have worked out over here that the big triangle is 3 times the size of the small triangle. So this width here is 3 times smaller than this. Work it out, it's going to be 12 divided by 3, which is going to be 4. That's 4 centimeters. Great, so now we work that out, I'm going to label it on our diagram at the top. So we know this length here is 5 centimeters. And so the width of the triangle, so in this case it's going to be the diameter of the base, is 4 centimeters. So what we can now do is use this information to work out the volume of the cone, so both the big cone and the little one. So for the large cone, and using, it says the formula for the volume of the cone in the box above. So for the large cone, the volume is going to equal a third times by pi times by radius squared, and radius is half the diameter, so it's going to be 6 squared multiplied by h, which is 15. And put that into the calculator, we're going to get 180 pi. So I'm going to leave this pi here for the minute just to make it a bit easier. Next, we're going to do the same thing for the small cone. So we're going to have a third multiplied by pi, multiplied by the radius, that's half the diameter, so 2 squared, multiplied by the height, so of the small cone that's 5, and using the calculator that's 20 over 3 pi. Great, so we've got these key numbers here, and from that we can work out the volume of the final shape. So volume, and if we look up at the diagram, we can see the shape, we can see that the volume of this is the volume of the large cone subtracting the volume of the smaller cone. So doing that, we're going to have 180 pi, subtract from that 20 over 3 pi. So that's 520 over 3 pi. And actually I need to put the units in here because volume is centimeters cubed. Now the last step, we're going to use this, that density is mass divided by volume. So the question asks us to work out the mass of the shape, and we know the density and the volume because the volume we just worked out and the density we told up in the question is 2.5 grams per centimetres cubed. So if I set this out, we're going to have 2.5 equals the mass divided by 520 over 3 pi. Now, if I multiply both sides by this, we're going to have that the mass equals 2.5 multiplied by 520 over 3 pi. And working that out into the calculator, we get 1361.36 to 2 decimal places. And that's grams in this case. And the question asks for an appropriate degree of accuracy here. So I'm going to round this to the nearest gram. This is going to be 1361. So we get the first mark in this box here. So using the similar triangle idea to work out the width here of being 4 centimeters, we get a second mark for using that to work out the volumes of the cone. We get another mark here for then using that to work out the volume of the shape. We get the next mark down here for going through the process, then use that to find out the mass. We get the final mark for the correct answer.